Okay, recording is starting. So the chapter from the beginning we will do now. The detergent part, soaps we did, antiseptic disinfectant we did, antibiotics we did, isn't it? Now the
Ma'am, could you please explain anionic detergents once again, ma'am?
who is this?
Chinmaya.
Anionic detergents. I draw I wrote the equation on the board. That part you want.
Yes, ma'am.
That time, why didn't you ask when I wrote on the board? See, if you don't understand, you ask end of this session. We will do that. Okay?
Okay,
Because
ma'am.
others will not. That time itself, you ask children if you have any doubt. Okay. Or while learning, you found it difficult.
Yes, ma'am.
Okay. Okay. End. You remind me. Okay.
Okay.
And we will do that. Okay, so the chapter, the beginning part, the difficult part almost done. The beginning, I am starting with the beginning of the chapter. So the topic is chemistry in everyday life. That means even if you don't like chemistry, but in your daily life, every phase of your life, you see chemistry. So out of that, there are so many things. The air you breathe, the food you eat, the house you live, everything chemistry is there. And here, the drugs, one part, drugs, medicines. Medicines are chemistry, isn't it? So the drug is the topic taken in this chapter. And soaps and detergents, that end part we have done. So the first topic is drugs. So here in the first chemotherapy, there is a definition in the first page. Use of chemicals for therapeutic effect is called chemotherapy. Okay, so sometimes some years back they asked the definition of chemotherapy. So underline that sentence. Use of chemicals for therapeutic effect, that is chemotherapy. Now the drugs can be classified. You see the next page, the classification of drugs.
Ma'am,
Ah,
what is therapeutic?
treatment of any disease. Therapy is that only, no? Okay. So, classification of drugs. First one is based on the pharmacological effect. So, pharmacological effect. Analgesics, have you heard about? We'll be learning later. Analgesics are painkillers, isn't it? Antipyretics are used for fever. For example, when fever comes, we take Dolo or paracetamol. They are antipyretic. And analgesics, even paracetamol is also an analgesic, painkiller. You get a relief from the pain, isn't it? So that is pharmacological. If you have fever, you take an antipyretic. So that is here the question. So the question they can give antiseptic, or antiseptic is yesterday we learned any antiseptic. For example, any antiseptic, for example, we learned antiseptic as 0.2% phenol, isn't it? Then we learned the tincture of iodine. These are all antiseptics. So the question can be, this antiseptic, suppose they say tincture of iodine is which type of a drug? Which classification? Okay, on the basis of which classification? It is on the basis of pharmacological effect. That way can be asked. Second classification is on the basis of drug action. Okay, so here there is a substance called histamine. Bio students, have you heard about histamines? Histamines are compounds which are responsible for the inflammation or swelling, when swelling comes in our body. Histamine, that is, one is it is responsible for swelling. Second one is cold, and cold, when you get histamines are responsible. And third one is acidity, there also histamines. And fourth one, allergy. So these compounds are responsible for that. And so for curing this, we take antihistamines medicines. Okay, So here the topic is based on the drug action. So if any of this problem comes, we have to take antihistamine, isn't it? So that is the classification. And the third one is based on the chemical
Ma'am.
structure.
Ma'am, for fever you told one, no? Like antiseptics and analgesics, you told for fever.
Pyretic, Pyretic, antipyretic.
Okay.
It is coming in the coming pages. Okay. So next classification is based on the chemical structure. So they have given a sulfonamide. So sulfonamides are having the particular structure. You just see that and understand. So the classification is based on the chemical structure. Fourth one is based on the molecular target. So the target can be carbohydrate, lipids, proteins, nucleic acid, etc. Okay. And now the chapter is starting. So here in the drugs, and the drugs. The first topic is drug target interaction. So when we do not want a particular reaction to take place or a particular thing to take place in our body, we take drugs, isn't it? Drugs means medicine. So there are two in your syllabus: drug target interaction. Target is which target we want to use the drug to which target. That is target, and then drug target interaction. So two are there. One is
drugs are basically inhibitors, right?
Drugs are
Basically inhibitors, right?
No. That is in the case of enzymes.
Okay.
Okay, so different target, different role, different. Okay, so in the first case, the target is an enzyme, then the drug will act as an inhibitor. Okay, so the first interaction is, I will go slow, you tell me if you do not follow, especially the non-bio students. The first one is enzyme drug interaction. Target is enzyme. And you know that enzymes are biochemical catalysts. There are various reactions taking place in our body, and the enzymes catalyze. Suppose we become sick due to one particular reaction in which enzyme is catalyzing. So we can, so because of that reaction, we are becoming sick. Then we can inhibit that enzyme. So how you will inhibit? You don't want that reaction to take place. Enzyme is the catalyst. So you will reduce the activity of the enzyme by taking drug. Clear this much? That is drug enzyme interaction. Have you understood?
Yes, ma'am.
So how it is happening? So luckily we learned surface chemistry, enzyme catalysis we learned, isn't it? There we learned that enzymes are having cavities of a particular shape. You remember? Enzymes are having cavities of a particular shape, having active groups, right? So there in that cavities, the reactant molecules will come, and like a key and lock, the reactant molecules will come to the cavities of the enzyme and the reaction takes place. Isn't it? So here we don't want that reactants to come and the reaction to take place. So we take drug or a medicine. So it can inhibit, like Anand said, it can inhibit the catalytic activity of the enzymes in two different ways. Okay, the first way is the drug itself come to the cavity and occupy. Then when the reactants come, already drug is occupying in the cavity. The reaction will not take place. Isn't it? Isn't it? So that is for one case. And the second case, the drug will not come to the particular cavity of the enzyme. Instead, somewhere else it will come. Such sites are called allosteric sites. Is it clear? So the drug can act as an inhibitor in two different ways. One is by occupying the cavity. When the reactants come, the drug is already in the cavity, the reaction will not take place and our aim is achieved. Another one, have you understood?
Yes,
Children,
ma'am.
I will go to the board and allosteric site I will explain. Suppose this is the enzyme having a particular shape cavity. Here, this is the cavity. And one way is the drug will come and occupy this cavity. Then the reactants cannot come, isn't it? If it is occupying, the reactants cannot come there and the reaction will not take place. And you learned in surface that each enzyme is having a cavity of a particular shape. And another one is the drug will come not in the cavity, somewhere else. That is allosteric site. So somewhere else in the enzyme, the drug will come. So when it comes, the shape will change because drug is coming on the enzyme. So the shape will change. If the shape is changed, suppose the shape is changed like this, then the reactant molecules, it is like a complementary shape, reactant molecules only will come. So here also, due to allosteric site, the shape changes and here also the reaction will not take place. Understood?
Ma'am? Ma'am, now if the drug is coming in place of the reactant, there will be another reaction taking place, no, ma'am?
What are you saying? Blood?
No, you said in that space, then instead of the reactant, the drug will come and occupy that space. So even if the drug comes, there will be a reaction, no?
No, that is not the reaction we want to stop. That will be a different one. The original reaction, because of that only we are becoming sick.
Okay, ma'am. So the reaction that occurs due to the drug will not affect in any way.
Those are the side effects. Anyway, our main aim is the original reaction. That should not take place.
Yeah.
Okay. Any other doubt? So you just understand this. Allosteric site can be asked as a question. That is enzyme drug interaction. See, I am near the board. You can ask any question if you have not followed. Is it okay?
Yes, ma'am.
So what you will normally drug enzyme interaction, the next page you can write. Drugs inhibit any of the mentioned activities of the enzymes. Drugs can block the binding site, that you said. Drugs can block the binding site of the enzyme and prevent the binding of the substrate. Substrate means reactant. And can inhibit the catalytic activities. So they are enzyme, those drugs are enzyme inhibitors. Now drugs inhibit by two different ways. One is compete with the natural substrate. That is what competing with the natural substrate. That is what I explained. It will go to the cavity and sit. That is competing. Okay. Second one is some drugs do not bind to the enzyme's active site. These bind to a different site of the enzyme called allosteric site. This binding inhibitor at the allosteric site changes the shape of the active site in such a way that substrate cannot recognize it. Understood? Any doubt in this?
No, ma'am.
So, next point they say the bond between the enzyme and the inhibitor is a strong covalent bond. Suppose the drug went to the cavity. No, diagram and all not required. It is suppose the drug went to the cavity and bound to the enzyme by strong bond, covalent bond, then that drug will not come out, isn't it? In that case, that enzyme will not be active anymore. Then the enzyme is blocked permanently. The body then degrades the enzyme inhibitor complex and synthesizes new enzyme. You understood? If the drug is bound to the enzyme by strong covalent bond, then that enzyme is permanently blocked and a new enzyme will be synthesized in the body. Okay, so that is about the first target. First target is enzyme. So second target is receptors. So receptors are used for body's communication process, and the receptors are present in the cell wall of the body. So communication processes, you know that the message from neurons will reach to the receptors. And so who will bring the message from the neurons? Substances called chemical messengers. They come and give the message to the receptors. And the receptors are present in the cell wall, and the receptors are protein molecules, and they are also having an active site which will project out of the cell wall. The active site will project out of the cell wall. And these are used for body's communication processes. So the messages from neurons will come to the receptors by some substances called chemical messengers. They bring the messages to the receptors. Okay, and so receptors are having an active site, having a particular shape, and when these messengers come with the information to the receptors, so there is a particular shape, active site. Then when they come, then the shape changes. When they occupy the active site of the messengers, the shape changes, and that causes the transfer of message to the cell. That is how it takes place. Understood? And so suppose any message, suppose I am having some pain, and so the pain, I feel the pain because the neurons send the messenger to the receptors. I don't want that message to come, so that I take a painkiller. Got it? So the drug is the painkiller, and so the drug will come. There are two different ways. One is, see, the drug will come and occupy the active site. So when the message comes of the pain, comes, then the messenger cannot transfer the message. So I get some relief of the pain. That is what. Got it? Understood?
Yes, ma'am.
So receptors are present in the cell wall, and they are involved in the body's communication process. And the receptors are having an active site which project out of the cell wall. And so the messages from neurons are different. I just gave an example of pain. The messages are transferred to the cell through the receptor. And the messages are brought from neurons to the receptor by substances called chemical messengers. And so suppose you don't want that message to go to the cell, then you take a drug. The drug will go and occupy the active site of the receptor so that the message cannot come to the cell. Okay, so that is the question. You just understand, and the next paragraph underline: drugs that bind to the receptor site and inhibit its natural function are called antagonists. Like I said, the painkiller when I take, it is antagonist. So that is a question. There are two terms, antagonist and agonist. So you understood what is antagonist? The drugs that bind to the receptor site and inhibits its natural function. They are called antagonists. And these are useful when blocking of message is required. Clear? which I explained. These are useful when blocking of message is required. Now, suppose we don't have, our body is not having enough chemical messengers. Then we take drugs which can mimic the chemical messenger. Have you understood? If we do not have enough chemical messenger, we can take drugs that will perform the duty of the messenger. So that is it. There are other types of drugs that mimic the natural messenger by switching on the receptor. They are called agonists. And these are useful when there is lack of natural chemical messenger. That is the question, the last small paragraph. Agonist and antagonist. Any doubt you can ask?
Ma'am, these ointments, right? Are they classified under the basis of drug action?
Ointments are antiseptics, no? Antiseptic creams. They are not
like the ones which we apply on swellings.
Those we are not taking inside our body, no? They are antiseptics.
Okay.
Okay, not the drugs. I am talking about the drugs we swallow, we take and eat that drug. Ointments are antiseptic. Okay.
Ma'am, the ones that are classified under drug action is only the ones that are taken orally?
Not like that. The first one for classification, antiseptic, is there, no? Pharmacological effect.
Yeah. Okay.
Okay. Any other doubt, children? So the question is agonist and antagonist. That paragraph you learn, and the explanation is there. Explanation they may not ask. And so all of you read that sentences 2-3 times. Antagonist and agonist. That is the question. The previous one, the enzyme inhibitor, allosteric site. Clear?
Yes, ma'am.
Any doubt you can ask, otherwise we will move to the next. Okay, we'll go to the next. Antacids. This one paragraph, 2 paragraphs, questions are there, children. Antacids, I will just say. Antacids, so you know what, if you eat spicy food or if you eat too much or if you do not eat, then also you get acidity, isn't it? Because why you do, if you do not eat, then acidity comes. You know that in the stomach, hydrochloric acid is the one which digests. Hydrochloric acid is produced in the stomach. So up to a particular limit, it is required for digestion. And so if you eat too much of food or spicy food, then more of hydrochloric acid will be produced in the stomach, and you can feel that burning sensation because of the production of acid. More acid will be, more than required will be produced. That causes acidity, isn't it? And if you do not eat also, because for a particular person, this much amount of hydrochloric acid is produced when we eat a normal healthy food. And so that much, if you do not eat also, that much amount of hydrochloric acid will be produced in the stomach. And so when no food is there, you feel that acidity, isn't it? So that is acidity. So the medicines used for treating acidity, they are antacids. Everybody must be knowing about antacids, isn't it? Now here the question, there are many questions. One, the first question, in olden days, for if you experience acidity, it is acid only, na? People used to take an alkali, and a sodium bicarbonate they used to take, so that the base will neutralize acid. That is the principle. And but when you take sodium bicarbonate, it is soluble. And so what happens when alkali is more, when you take more, that triggers the production of more acid. So people stop taking sodium bicarbonate? Because that is the question. I will tell you to underline. Because what is the disadvantage of sodium bicarbonate? It
It's an
triggers.
acid salt. It's an acid salt. Acidic.
It can trigger the production of acid, more acid. Okay. And so that is the sodium bicarbonate. Then people, now we don't take sodium bicarbonate when acidity comes, isn't it? We take Digene or say Zintac, Rantac, all that we take, isn't it? So sodium bicarbonate, the question, the point is that it triggers acidity. And so second, they started taking magnesium hydroxide. And magnesium hydroxide, one advantage is there, it is insoluble. So it will not increase the pH above neutrality. Okay. So even if it added, it will come to around 7 only. It will not increase the pH because it is insoluble. That is the second question. Now, the third question, these sodium bicarbonate or magnesium hydroxide, these are bases. These bases, they give you relief, or temporary relief only you get. It will not cure the cause. Whatever some reason will be there, that is not cured by taking this alkalis or bases. So what happened? Later, the medicines which cure the root cause of the acidity, that cure, they are called the medicines which we now say Zintac, Rantac. These are all that cimetidine. So these terms which I am saying, they can ask. Okay. So what these drugs do? Here, I told you in the beginning, there is a compound called histamine. Histamine is responsible for inflammation, that is responsible for cold and allergy, and the same substance is responsible for this acidity. Okay. So what histamine does, it interacts with the receptors present in the stomach wall. And when it interacts, more acid will be produced. That is why acidity comes. So we have to prevent the interaction of histamine with the stomach wall. So we take antihistamines, antacids. That will prevent the interaction of histamine with the stomach wall, and so less acid is produced. That is the point. Have you understood?
Yes, ma'am.
Yes, ma'am.
So there are so many questions. I will, once when I read, I will say the questions. So these are the explanation. Now I will read the book, you underline. Any doubt you can still ask. Okay. So here, the first one is the third sentence. Excessive hydrogen carbonate can make the stomach alkaline. Underline that. Excessive hydrogen carbonate can make the stomach alkaline and trigger the production of even more acid. Underlined? So that is first question. What is the disadvantage of sodium hydrogen carbonate or potassium hydrogen carbonate? Okay. So the answer you underline. Excessive hydrogen carbonate can make the stomach alkaline and trigger the production of more acid. Now the next question. Metal hydroxides are better alternative because being insoluble, underline, being insoluble, they do not increase the pH above neutrality. So these are board questions. Second one, hydroxides, underlined. Now the third one, why these treatments control only symptoms, underline, and not the cause. Therefore, with these metal salts, patients cannot be treated easily. So, next one, a major breakthrough in the treatment of hyperacidity is by the discovery of cimetidine. Cimetidine is, okay, you underline just the medicine, cimetidine. So next sentence you are going to underline. This prevents the interaction of histamine. Have you seen that sentence? This prevents the interaction of histamine with the receptors present in the stomach wall. This resulted in the release of less amount of acid. Okay. So then the examples, you should have an idea. Histamine, cimetidine, ranitidine, Zintac, Rantac, these are all antacids. Clear? So 3 questions are there in antacids.
Ma'am, are these structures also
No. Structures not required. But it's not very easy. See, if you do not learn now, then till the end, see, you can ask your seniors which is the most difficult chapter. They will say the end chapters, because that is, you have to just sit and learn by heart once, but then correctly. What I said, underline that should be very thorough. Okay, so structures not required. Similarly, that Dettol, yesterday I said, there the name of the components required, not the structure. Okay. Now the next one, antihistamines. So one antihistamine is an antacid. And see, I'll tell you another question. This histamine is responsible for acidity, and histamine is responsible for cold and congestion. Histamine is responsible for allergy. So, see, for acidity, we take Rantac, isn't it? And so then you may be thinking, for cold also we can take Rantac, but we take Avil or cetirizine. Why we are taking all our histamines only? We are targeting histamines. Why are we taking different medicines? That is the question asked once. Can you say the reason? You understood the question? You understood the question, children?
The effect area of histamine is different in the cases.
That is it. That is because the histamine is acting on different receptors. For antacid, that is acting on the stomach receptors. So the histamine present in it is acting on different receptors. That is why we cannot take a common medicine. Have you understood? That is one question. And then the histamine, about histamine here they are saying, histamine is a potent vasodilator. It has various functions. It contracts the smooth muscles. It has functions also. It contracts the smooth muscles in the bronchi and gut and relaxes other muscles, such as those in the wall of the blood vessel. Histamine is responsible for nasal congestion and associated common cold and allergy. So here, Dimetapp, they asked once, synthetic drugs. So you don't have to learn by heart, but some should have some idea. Okay, they may ask you, give these medicines and ask you which is a antihistamine. So you should have an idea. Okay, they interfere with the natural.
Ma'am, should we underline this first paragraph? Histamine is a potent vasodilator. The first paragraph, histamine is a potent vasodilator.
Suppose they ask you, so far I haven't seen that question, but if they ask you to explain about histamine, then that underline that and learn. They can ask anything. Okay. Now here the question which I ask is coming. Why do the above mentioned antihistamines not affect the secretion of acid in the stomach? That you underline. The reason is that anti-allergic and antacid drugs work on different receptors. Got the point?
Yes, ma'am.
Ma'am, my network stopped. Can you repeat the point?
You underline that. You only told me the answer. Okay. Why this? Why we are not using? See, for antacid, histamine is responsible. For cold, histamine. So then we can take one same medicine for both, na? But that we don't do. We take different medicines. Why? They are acting on different receptors. That is the last sentence. The reason is that anti-allergic and antacid drugs work on different receptors. Okay?
Got it, ma'am.
So that is about antacids. And now tranquilizers. Here also many questions. What are tranquilizers? See, for mental stress, strain, depression, all that people take medicine, antidepressant. You must have heard about antidepressant. And some people have depression, anxiety disorder. They are very, very anxious about their future, or even some children have. I hope you all don't have depression. You are all pleasant children, isn't it? So this, when you have a depression or anxiety, you take antidepressant. They are tranquilizers. Okay. So I will explain, then come to the textbook. So antidepressants actually, so when we see mood swing, sometimes we feel very good. Sometimes we feel very low, isn't it? So we say moody. If the person is moody, we say mood swings. The reason is that noradrenaline. It is the reason for mood swing is noradrenaline, and if in our body the noradrenaline level is less, then we feel low, and we say moody. We feel moody. We don't feel good. Okay, so these antidepressants or tranquilizer, they when we take that, so the level of noradrenaline is down due to some reactions which are catalyzed by enzymes. So what we do when we take the antidepressants, they will inhibit the catalytic action of the enzyme, so that the noradrenaline level will not go down. Got the point? So that is tranquilizer. Any doubt?
This noradrenaline was a bit confusing, ma'am.
It is a neurotransmitter. See, noradrenaline, if in our body, if in my body noradrenaline level is high, means I am a happy person. If in my body the noradrenaline level is, it is a neurotransmitter. If the level is less, then I don't feel good. I get irritated, moody, anxious, anxiety. What?
Ma'am, how is it regulated? Like, does it vary from person to person?
So it is like, see, when the level is going down due to some reactions which are catalyzed by enzymes. Okay, so then that enzyme is inhibited. Then that reaction will stop. So the level will come. Okay.
Okay, ma'am. Yes, ma'am.
So then you may be thinking, if depression and all, people say do yoga, do other things, isn't it? Think about other things you do, then how? These are all the production of the enzyme. This all will affect the whatever the mechanism. So when due to some reason, so maybe sometimes the level is going down, then this happens. And so such people, this antidepressant will be given. Immediately the mood will become all right. You feel very happy. When you take antidepressant, you feel very happy. And that doesn't mean if you feel sad, go and take antidepressant. These are all having side effects. Okay. So here, coming to the textbook, first question is tranquilizer definition, like antibiotic. Okay. So tranquilizers are a class of, you can write the definition, tranquilizers are neurologically active drugs. First sentence. They are neurologically active drugs. And so that even analgesics are painkillers. Analgesics, they are neurologically active drugs. And tranquilizers are a class of chemical compounds used for the treatment of stress and mild or even severe mental diseases. They relieve anxiety, stress, irritability, or excitement. So anything you can write. They are a class of chemical compounds used for that is enough. If they ask you the definition, okay? Class of chemical compounds used for the treatment of stress and mild or even severe mental diseases. Got it? First you will say they are neurologically active drugs and this sentence. Okay. They form an essential component of sleeping pills. Okay. There are various tranquilizers. And now the next question is about noradrenaline. So for noradrenaline, that are you underline. Noradrenaline is one of the neurotransmitters that plays a role in the mood changes. If noradrenaline is low for some reason, then the person suffers from depression. Underlined? In such cases, antidepressant drugs are required. So, now how these tranquilizers or antidepressant drugs are acting? That is the next question. So that then these drugs inhibit the enzymes which catalyze the degradation of noradrenaline. Underline that. They inhibit the enzymes which catalyze the degradation of noradrenaline. If the enzyme is inhibited, then this neurotransmitter is slowly metabolized and can activate the receptor for a longer. That also not required. If they ask you how they act, these drugs inhibit the enzymes which catalyze the degradation of noradrenaline. That is enough. Okay. Now the examples. Examples, you have to learn equanyl. Name, you have to learn equanyl and veronal. Okay. So barbituric acid, derivatives of barbituric acid, underline. They are tranquilizers. Barbiturates. And then barbiturates are hypnotic. Okay. So the names are required. Veronal and all, they asked Valium, serotonin. So you should have some idea. They will ask a number of drugs will be given, which is a tranquilizer.
Ma'am, it is written that derivatives of barbituric, that sentence is given seconal constitute. What is seconal?
Where it is?
That sentence, ma'am, derivatives of barbituric acid.
Seconal is another one. Luminal, these are all derivatives. See,
okay, so seconal constitute an important...
Veronal, amital, seconal, they are all the derivatives. They constitute an important class of tranquilizer.
So the barbiturates are important class of tranquilizers.
They are hypnotic. So all that, some idea you should be having about the names. Okay. So even though it is a small chapter, you see how many questions are there. The names and other questions they asked. One frequently asked is the definition. Then ask about noradrenaline and then how the antidepressants act. Then example.
Ma'am, isn't veronal kind of poisonous, ma'am?
No. All
I
in
heard
limited,
somewhere it's like higher dosage is harmful.
Higher dosage you will die. Sleeping pills you will die.
Oh.
And everything under prescription only you should take. And you should avoid that. Do not go into depression and all. See, some level of hormones and all based on our thinking also the secretion depends. So anything in overdose, you will die only. So people who commit suicide by taking overdose of the sleeping pills. All this sleeping pills also contains tranquilizer, isn't it? So we should not take sleeping pills. And I know that for you, more sleep is the problem, not lack of sleep. Anybody is having problem with lack of sleep? I don't think. Okay, so that is about tranquilizers. And so we'll go to the next topic. Abhishek's one question: any charge exists in the colloidal? Colloidal particles are charged only, Abhishek, and it is found by you can prove that colloidal particles are charged particles by electrophoresis. Understood, Abhishek? Okay. So any doubt? Tranquilizer clear? Say yes or no.
Yes, ma'am.
Yes, ma'am.
Why do you do not react? Only Naomi, Vishnupriya, Chinmaya, only, and this Amitav, Anand, Bas. Remaining are sleeping. Okay. So next class is analgesics. One sentence already we learned. They are neurologically active drugs. Analgesics are neurologically active drugs. And so analgesics also, they are painkillers, if for understanding that. Painkillers. And so questions, write a note on analgesics, tranquilizer, like that. This year also they asked antiseptic, different, and antibiotic. So that way questions are there. And so analgesics, they are painkillers. And so there are two types of analgesics. And first one is narcotic and non-narcotic. Narcotic means, non-narcotic means you do not become addictive. See, narcotic are the painkillers. See, the drugs. Drugs means you don't think about the capsules or tablet, the other drugs. So they are addicted. People get addicted to drugs, isn't it? So you know that they are analgesics. If you take drugs, you don't feel anything. You don't feel pain. You feel very happy. That is why those who are addicted, they take that drugs. Okay. So then you may be thinking why it is coming under drugs here, analgesics, because they also relieve you from pain. In fact, they relieve you from pain, unbearable pain. It is very effective. The narcotic drugs, opium, all that. In lower dose they give. So especially for patients having this cancer, and in the last stage and all, the cancer, it is very painful. So they give this drugs.
Ma'am,
Huh.
narcotic drugs, are they medically prescribed?
Medically prescribed, yes. It is for terminal illness. Those who are having cancer in the last stages, especially stomach cancer and all, very, very painful. And so normal painkillers will not work. So it is very difficult to get that doctor's prescription you will get, and then they give that. So then the pain goes for some time. So that is unbearable pain, and then the last stage of their life, and we cannot see them suffering with the pain. So then that time they give these drugs. Okay. And
Ma'am, so does it create the same effect, like other than reducing pain, like feeling
they will
sleepy?
sleep off. They sleep off. And I have given that to my mother. My mother was having it. So I personally experienced that. My mother was having the cancer in the final stages. It is unbearable pain. So my brother is a doctor, so he managed some. And it is unbearable. And the people who are with that patients, it is more difficult. And I could not tolerate. I used to give. When I used to give her, then she used to sleep. Then the pain will go for some time on the sleep. So I personally experienced that. And so it is very, very, very painful. And the people, the dear and near ones, it is more painful. I used to have some sort of chest pain all those days continuously. It is very difficult to see your mother suffering. So we used to give, and at that time, I don't know, my brother used to bring. He is a doctor. It is not very easy to get, and he used to bring that, and we used to give because, and then she sleeps off, and so that way it is. That is narcotic drugs. Okay, and so we will go to the analgesics. Analgesics, first one is the definition. Analgesics reduce or abolish pain without causing impairment of consciousness, mental confusion, incoordination, or paralysis. You will learn that sentence, okay? So without these, you will get the pain relieved, okay? I'll read that sentence. They reduce or abolish pain without causing impairment of consciousness. You don't become unconscious. Mental confusion or incoordination or paralysis. There are two types, narcotic and non-narcotic. Non-narcotic is like aspirin, paracetamol. These are all analgesics, isn't it? And so we don't get addicted to that. When we get a pain, see, one day if I take a dolo, again I don't feel like taking the dolo. It is that way. I don't become addicted to that. That is why they are called non-narcotic. And so aspirin and paracetamol belong to this. Aspirin questions are there, I will tell. Aspirin, you know, heart patients take aspirin, isn't it? So aspirin inhibits the synthesis of chemicals called prostaglandins, which
Blood
stimulate
thinner. Aspirin is a blood thinner right now.
blood thinner. That is a different question. Here the first they said aspirin inhibits the synthesis of chemicals known as prostaglandins, which stimulate inflammation in the tissue and cause pain. So this is the question, how aspirin is relieving the pain. Got it? So underline that. This is two functions aspirin is having. The first one, the sentence which I read is how aspirin relieves the pain. Aspirin inhibits the synthesis of chemicals called prostaglandins, which stimulate. The prostaglandins stimulate inflammation in the tissue and cause pain. So it inhibits the synthesis of prostaglandin. Understood?
Yes, ma'am.
So
Yes, ma'am.
underline that. That is how it is used as a painkiller. Okay. These drugs are effective in relieving skeletal pains due to arthritis. These have many other effects. So aspirin is an antipyretic. Here, Naomi, the word is coming. Reducing fever, antipyretic. That also they asked once. Antipyretic is used for reducing the fever. Underline that. And preventing platelet coagulation. And last sentence, like Anand said, because of the anti-blood clotting action, aspirin finds use in the prevention of heart attack. That also is asked. It is used as a blood thinner. So that is, you underline that because of its anti-blood clotting action. Because of its anti-blood clotting action, it is used in the prevention of heart attacks. So 3 questions from there, underlined. Prostaglandin
Yes, ma'am.
also they asked. Narcotic drugs, I said morphine and many homologs when administered in medicinal doses relieve pain and produce sleep. In poisonous doses, they produce, it is ultimately death. So opium, all that prescribed, they will say the dosage if you give. These are used for relief of post-operative pains. Okay.
Ma'am, what is stupor?
What is?
What is stupor? STUPOR.
Where it is?
Ma'am, it is given that in poisonous doses these produce stupor.
Stupor, I don't know. Comma, maybe some stage, I'll tell you, some state. Stupor. unconsciousness. Okay, state of unconsciousness. So that is about narcotic drugs. Now, antibiotics we learned, isn't it? Antiseptic we learned, and anti-fertility drugs. Anti-fertility drugs, you know that for fertility reason, here the name only you anti-fertility reason for the name anti-fertility drugs name norethindrone and novostrol. So that names only you will learn. Anti-fertility. They may not ask you anything else. Then the chemicals in food. These are important. Chemicals, artificial sweetening agent. Artificial sweetening agent. Here questions are there. Next page. You come to next page. Aspartame is the most successful and widely used artificial sweetener, and it is 100 times as name you underline. And but the last sentence, it is used only for cold drinks. For hot cases, then it decomposes. So the last sentence, use of aspartame is limited to cold foods and soft drinks because it is unstable at cooking temperature. Okay, that is about aspartame. Then allitame. Allitame name they ask. Allitame is also it is stable than aspartame. The control of sweetness is difficult. That once they asked. What is the problem with allitame? You understood? It is very sweet and you cannot control the sweetness. That sucralose is a derivative of sucrose and it is stable at cooking temperature. It does not provide calories. That also once they asked. What is the advantage of taking this artificial sweeteners? One is, you know, that people who are diabetic, isn't it? And then sucralose, in sucralose it is given underline, it does not provide calorie. That is the second. That 2 points you have to write, isn't it? The second point, it does not provide calorie. It doesn't increase. It doesn't increase. They should not take sweets or sugar. Diabetic patients, but some people cannot drink tea or coffee without sugar, so they put this sweetener. And so food preservative, here also food preservative definition. Food preservatives prevent spoilage of food due to microbial growth. And sodium benzoate is the most commonly used. And another one, salts of sorbic acid and propanoic acid are also used. Sodium benzoate underline. And okay, so that is it. The chapter is over. And so if
Ma'am, chemicals in food, the first paragraph, nothing important. Like there are some points which are given.
No.
Many categories of food additives and all that.
No.
Okay.
So this much. And coming to the questions, exercise are all almost direct questions, index questions, sleeping pills by doctors. That you know that, no? If overdose will act as poison and even cause death. With reference to, this is the question I said. With reference to which classification has that statement? Ranitidine is an antacid. So this is due to classification based on pharmacological effect. In-text question. Got it?
Yes, ma'am.
Now, why do we require artificial sweeteners? To reduce the calorie intake and to protect from diabetes. Preparation of soap from, write the chemical reaction. Preparation of soap from glyceryl palmitate. That is easy. So preparation of soap from glyceryl palmitate. One I will write, second you write as homework. Okay. This is the ester. C15 H31 COO thrice C3 H5. So, like we learned yesterday, OOC C15 H31 CHOOC C15 H31 CH2OOC C15 H31. Right? You write like this. Can you see? This is the ester hydrolysis, NaOH. Isn't it? So soap is the sodium salt. C15 H31 COONA. This is soap. The byproduct will be glycerol. CH2OH, CHOH, CH2OH. Isn't it? Understood? Understood, children?
Yes, ma'am.
Ma'am, what is the last part that you've written after the soap?
Glycerol, CH2OH, CHOH, CH2OH.
Okay, yeah.
Okay. So that way, they gave the ester like this. So you write it like this. So it is easy. Okay. Now the next question, 16.5. Label the hydrophilic and hydrophobic part. You see the question? Label the hydrophilic and hydrophobic part. This is done. This is the hydrophobic part. Hydrocarbon part. This is hydrophilic part. This one. This is hydrophobic. Right? Okay. And two questions. Second question, which is the functional group? This is an ether. Here, two functional groups are there. Ether, and this is a primary alcohol. Primary alcohol. CH2OH is a primary alcohol, last one. This oxygen connected to two different groups. This is an ether group. Clear?
Ma'am? Ma'am, which part is polar and which part is non-polar?
Non-polar is hydrophobic, this part. Hydrocarbon part is non-polar. Okay?
Yes, ma'am.
Last question in the exercise. Remaining are all direct questions only. Last question in the exercise. Label the hydrophilic and hydrophobic part. Have you seen that? So I will write the hydrophilic and hydrophobic part. Last question. This is hydrophobic. This is hydrophilic, isn't it? Next one. CH3, CH2, 10 times, 15 times, N plus, CH3 thrice, Br.
Ma'am, how do you determine which is hydrophobic and philic?
Hydrocarbon part is hydrophobic. Any
Sorry,
ion
ma'am?
present, hydrocarbon part is hydrophobic. Where
Okay.
ions present, it is hydrophilic.
Yeah.
So hydrophobic. This is hydrophilic. And the last one, CH3, CH2, 16. That is, isn't it? CH3, CH2, 16. This will be the hydrophobic.
Hydrophilic.
Hydrophobic.
Phobic part, ma'am.
COO, this will be hydrophilic. CH2, CH2O n times CH2, CH2OH. Isn't it? This will be hydrophobic. Other questions are direct questions. You have to go through that and learn.